Hi, in this video we'll look at network layer of OSI model. So we'll go into its very great details to understand this layer and figure out how the packets flow on the internet. So that when we are doing a network scan with NMAP, we know how things works. Anyway, this is the second video that we are doing on network fundamentals. The first one was on OSI model in general, and in this video we'll discuss the network layer. So once again we are studying OSI model because it allows us to understand how things works in NMAP and in a network scanning in general in a much better way. In order to get started, the first question we need to ask ourselves is, what is a network layer? Well, the network layer is used for the transfer or flow of packets across the network. What that means is this layer is used for how packets are going to transfer across the network. Now for doing that, it uses certain protocols in order to keep everything according to the standards. And those protocols are standard all over the world. Now you might have heard their names before because they are quite common. So the first protocol that it uses is IP or Internet Protocol, which has some subparts as well that gets denoted by IPv4 and IPv6, which is the latest one. The Internet Protocol specifies format of packets as well as it contains the addressing information that enables the packets to be routed correctly. In simpler words, the Internet Protocol tells the format of packets as well as it contains the addressing info, like where the packets are coming from and where should the packets be sent out, that kind of info. Now the main job of Internet Protocol is to provide only the functions that are necessary to deliver a packet from a source to destination over an internet or over an interconnected system network or something like that. Now the purpose of this protocol is to make sure that the packets get sent out safely and it reaches the destination safely as well as efficiently. Now let's look at the differences between IPv4 and IPv6. Beside IPv4 is an older version and IPv6 is a newer version, there are a little bit differences in both of them. So let's understand them by looking at their headers first. So this way we will understand two things. The first one would be, what are headers? Because it's really important for an ethical hacker to understand packet headers because it contains very valuable information which we can exploit and which we can get. And the next thing would be to understand the differences between IPv4 and IPv6. So let's first look at IPv4 packet header. The IPv4 protocol defines many different fields in their headers. These fields contains binary values that IPv4 services reference as they forward packets across the network. Now the information it forwards across is firstly, as you can see on the screen, the information about the IP source address or the packet source, or you can say where the packet is coming from. Secondly, it stores IP of destination address or the packet destination or where the packet is destined for, where the packet is going to. Now the third one is time to live. Don't get scared because it's pretty simple to understand. It's just an 8-bit value that indicates the remaining life of the packet or for how much time a packet will be in transit until it gets destroyed or reach its destination. Now the next thing that IPv4 takes in its header is the type of service. The type of service field contains the same 8-bit binary value that is used to determine the priority of each packet. So it's the type of service that is responsible for prioritizing the packets. And after that we have the protocol. It's also an 8-bit value that indicates the data payload type that a packet is carrying. Now to conclude the IPv4 packet headers, it contains all the info required to transmit a packet from source to destination. That is the source IP, the destination IP, the time to live, and other two things which we have discussed earlier. Now coming towards IPv6. An IPv6 address is 4 times larger than IPv4, but surprisingly, the header of an IPv6 address is only 2 times larger than IPv4. Now IPv6 headers contains one fixed header and 0 or more optional extension headers, which is a conversation for another time. But what we need to understand is all of the necessary information that is essential for a router is kept in a fixed header. And the extension header contains optional information that helps the router to understand how to handle the packet flow. So we have already seen what's inside the IPv4 header. Now let's also look at IPv6 headers and understand what it contains. The first thing it contains is version, which is a 4-bit digit, and it represents the version of internet protocol it uses for packet transfer, which could be like 0110 or something like that. The next thing that IPv6 packet header has is traffic class, which is an 8-bit digit, and it's divided into two parts. The most significant 6 bits are used for type of service to let the router know what services should be provided to this packet. And the last significant 2 figures, or the last significant 2 bits, are used for explicit congestion notification. Now, if these are a little bit difficult for you, don't worry, we will discuss these while we are doing a network scan, but right over here I'm just going through these things so that once we go to the NMAP and we discuss the network scan, so you are able to understand these things. Don't worry, right over here, just go through the video, and if you don't understand, just don't worry, we'll discuss these in very great details later on. Now after that we have flow label, which is a 20-bit digit and is used to maintain the sequential flow of the packet belonging to a communication. Now the source label in it is a sequence to help the router identify that a particular packet belongs to specific flow of information. This field helps avoid reordering of data packets. It is destined for streaming of real-time media. After that we have next header, and next header is a name, which is an 8-bit digit. This field is used to indicate either the type of extension header, or if the extension header is not present, then it indicates the upper layer or PDU. Then next we have is hop limit, which is 8-bit digit. This field is used to stop packet to loop in the network infinitely. This is same as time to live in IPv4. The value of hop limit field is decremented by 1 as it passes a link, a router, or a hop, whatever you want to call it. When the field reaches 0, the packet is discarded. And after that we have destination address, which we have already discussed in IPv4. This field provides the address of intended recipient of the packet, or where the packet should be sent, or where the packet is destined to. And in the last we have source address. This field indicates the address of originator of the packet, or where the packet is sent from. Now at this point I'm sure you have understood what network layer is and how it's used, and I'm sure that there are no problems in understanding how the packets are transferred in a network layer. We'll discuss this layer in a much more details in our upcoming videos, where we will look at scanning using NMAP, but this is just an intro to what it is and how things works behind the scenes. So this is pretty much it for this video. Till next time, I'm out. Peace.